Today we took a look at how to make quick graphs of linear equations. Last week when we looked at linear equations, we went ahead and made a complete table of values, 5 x's, substituted each one of those x's individually into the function, paired it with a y, plotted those 5 points, and went ahead and made our graph from those 5. Eventually we found out that, geometrically speaking, you only need 2 points in order to make a graph. Now we're going to look at a way to generate 2 points quickly so that we can graph linear equations. A couple of quick terms: the y-intercept. Y-intercept is the y-coordinate of the point where the line crosses the x-axis. And in particular, you probably remember from Algebra 1, linear functions written in slope-intercept form. So a linear equation written in the form y equals mx plus b is in slope-intercept form, where b is your y-intercept and m is your slope. Let's look at an example of how we would use that. In order to graph the line y equals 2/3 x plus 3, the first thing we need to do is identify which of these is our y-intercept and to identify the slope number. What we saw from our definition above, in the form y equals mx plus b, y equals some number times x plus a number, the y-intercept is that constant, the number by itself with no variable part. In this example, that's 3. Great, so now that we know that the y-intercept is 3, what can we do with that? Well, we know that's the point where this line crosses the y-axis, so we want to mark that with a point. The y-intercept of positive 3, we're going to begin at the origin, count up 3 units, and place a point there. Next, we need to identify the slope number, which we know is the multiplier on x. In this case, that slope is 2/3. What does that tell us? Remember, slope is the change in y divided by the change in x. So the numerator of that fraction tells us how far we're going to move up or down if it's negative in order to find another point that's on this line. The denominator, the 3, tells us how far we're going to move to the right. So we went up 2 and 3 to the right. Geometrically speaking, 2 points is all I need to make a line. I could use a straight edge and draw this line in. But it's important, I think, that we develop a habit of becoming more meticulous in plotting our lines. So I'm going to go ahead and use that slope again, working backwards and down, in order to be able to place one more point. Then we can graph that line. This is graphing from slope-intercept form. We also want to think about this idea of an x-intercept. If the y-intercept is the point where this line crosses the y-axis, I think I wrote that down incorrectly, y-axis, well, the x-intercept is going to be the x-coordinate, or the point where the line crosses the x-axis. And this comes in handy when we have lines that come to us in standard form. Standard form is the linear equation in the form ax plus by equals c. Both the a and the b on the same side of the equal sign, the constant by itself on the other side. Let's look at an example of using that. In order to graph equations in standard form, we need to make sure that we have a standard form equation. Ax plus by equals c. We're going to find our x and y intercepts. That's how we're going to generate our 2 points. The important thing to keep in mind is if I have a point that's on the y-axis, its x-coordinate is automatically going to be 0. When I start at the origin, how far did I move left or right? Well, none at all. My x-coordinate is going to be 0. If I've got a point that's on the x-axis, I ask myself, what's its y-coordinate? How far did I move up or down from along the x-axis? None at all. And so I want to use that to my benefit. If I have a point that's on a line, the x and y coordinates are going to make a true statement out of my equation. So if I know the x value, say for instance, is 0, I can plug that in, solve for y, and that'll give me my y-intercept. Let's see what that looks like. You may remember a teacher, perhaps an Algebra 1 teacher, or maybe even a middle school teacher, that had you cover up the x portion of the equation with your pencil and just solve what was remaining. Why did they want you to do that? Well, I know if I put x in for 0, I know because of that this point will lie on my y-axis. So let's substitute that in, and let me find the y that goes with that. 5 times 0 is 0. It's going to go away. I'm left with this equation, 2y equals 10. Divide both sides by 2, and y equals 5. So I know I have a point with the coordinates 0, 5 that's on my line. So let's place that point there. Likewise, we're going to go back, substitute 0 in for y. I know if I have a point that's on the x-axis, its y-coordinate is going to be 0. Let's use that to our benefit to find out what this point is. So 5x equals 10. Divide both sides by 5, and x equals 2. So I know I have a point at 2, 0. So again, generating 2 points, I've got a line. Last thing we want to look at, I don't have an example of this for you, but just to give you the definition, and you can use this for your assignment. Parallel and perpendicular lines. Our eyes can fool us when we look at a graph. Just because two lines look parallel when they're drawn doesn't mean that they're never ever going to touch if we move outside of the small window that we're looking at. But we can know algebraically. How is that? If two lines are parallel, they have the same slope. If they have the same slope, they'll always move up and over at the same rate, and they'll never touch. And so we say the lines are parallel if and only if they have the same slope. If and only if sounds like we're being really dramatic and trying to make an emphasis, but it's actually a legitimate logical statement. What that says is that we can read these two clauses backwards, and they're also true. If two lines have the same slope, then they are parallel. So if we know the slopes, we can convince ourselves that the two lines are parallel. Similarly with perpendicular lines. The lines are perpendicular if and only if their slopes are negative reciprocals of one another. If I take the two slopes and multiply them together, and they equal -1, that tells me the two lines are perpendicular. Similarly, if and only if. So if the two slopes are negative reciprocals, then they are perpendicular. If two lines are perpendicular, then I have negative slopes. So go ahead and try out the assignment for section 2.4. We'll take a look at the assignment when we get back together in class tomorrow and move on into 2.5, which is writing equations.